would like to continue to the overview of computer system structure. Okay, we look at here. This is computer system organization. We can see that input and output devices and the CPU can execute concurrently, and each device controller is in charge of a particular device type, and they has a local buffer and operating system device driver to manage it. CPU move data from main memory to local buffer or from local buffer to main memory. Input and output is from the device to local buffer of controller, and the last one is device controller informs CPU that it has finished its operation by causing an interrupt. We talk about interrupt. What is the common function of interrupt? Okay, the first one is interrupt transfer control to the interrupt service routine, generally through the interrupt vector, which contains the addresses of all the service routine. And the second one is the interrupt architecture must save the address of the interrupted instruction. And the third one is a trap or exception is a software generated interrupt caused either by an error or a user request. And the last one is an operating system is interrupt driver. So this is interrupt timeline. So how do we handle the interrupt? Okay, the first one is the operating system preserve the state of the CPU by storing the register and the program counter. And the second one is determine which type of interrupt has occurred. And the last one is separate segment of code determine what actions should be taken for each type of interrupt. Okay, we look at here. This is interrupt driven input and output cycle. And we see the first one is device driver initiate input output, go to initiate input output. The third one is input ready output complete or error generate interrupt signal. And the fourth one, CPU receiving interrupt transfer control to interrupt handler. The fifth one, interrupt handler processing data return from the interrupt. The sixth one is CPU resumes processing of interrupt task. And the last one, they go back to the device driver initiate input and output. Okay, what is this called? They have two methods for handling input and output. The first one is after input and output starts, control return to user program only upon input and output completion. And the second one is after input and output starts, control return to user program without waiting for input and output completion. Okay. The last one is computer startup. Grab program is loaded at power up or reboot. And the first one typically stored in ROM or EPROM, generally known as firmware, initialize all aspects of system. And the last one is loads operating system kernel and start execution. I think that's it. Thank you.
Now, let's look about storage structure. The storage structure can access directly through random access, typically volatile and typically random access memory in the form of dynamic random access memory. Hard disk drive is a rigid metal or glass pattern that covered with magnetic recording materials, and the disk surface is logically divided into tracks which are subdivided into sectors. The disk controller determines the logical interaction between the device and the computer. For the non-volatile memory devices, it is faster than hard disk, and it becoming more popular as capacity and performance increases and price drops. Storage system organized in hierarchy, which is speed, cost, and volatility. The caching means copying information into faster storage system. Main memory can be viewed as a cache for secondary storage. Device driver for each device controller to manage input or output will provide uniform interface between controller and kernel. Direct memory access structure is used for high-speed input or output devices able to transmit information at close to memory speeds. Next, for the operating system operations, bootstrap program, which is simple code to initialize the system to load the kernel, and for the kernel interrupt driven, got two, which is hardware interrupt and software interrupt. Software interrupt consists of software error, system call, and infinite loop. And for the multi-programming is used for organized job. One job will be selected and run via job scheduling. is about the multitasking, which also called time sharing, which the response time should be less than 1 second. If several jobs ready to run at the same time, we call that CPU scheduling. And for the virtual memory, will allow execution of processes not completely in memory. The dual mode operation allows OS to protect itself and other system components, which is user mode and kernel mode. The timer is used to prevent infinite loop or process hogging resources. Timer is set to interrupt the computer after some time period, keep a counter that is decremented by physical clock. Operating system set the counter, and when counter 0 generate an interrupt set up before scheduling process to regain control or terminate program that exceeds allotted time.
Next subtopic is about process management. Number 1, resources needed. Processors require resources like CPU, memory, I/O operations. Number 2, termination. When a process is done, we need to reclaim reusable resources. Number 3, single-threaded. It means following instructions one at a time until completion. Number 4, multi-threaded. Multiple to-do lists for efficiency. And lastly, concurrency is achieved by using sharing CPU time among processes or threads. The process management activities are creating and deleting both user and system processes, suspending and resuming processes, providing mechanisms for process synchronization, process communication, and for deadlock handling. Memory management. The key memory management tasks are tracking currently used memory segments and their owners, deciding which processes or data to load into or remove from memory, and allocating and releasing memory space as required. Next, file system management. Files are usually organized into directories for better organization. The operating system activities are create and delete files and directories, provide basic operations for manipulating files and directories, map files onto secondary storage devices, and ensure backup of files onto stable, non-volatile storage media. The OS activities for mass storage management are mounting and unmounting, free space management, storage allocation, disk scheduling, partitioning, and protection. The purpose of caching is speed up data retrieval, reduce load on the original data source, and enhance user experience and system efficiency. So this is the flow of migration of data A from magnetic disk to hardware register. I/O subsystem. The I/O subsystem is responsible for memory management of I/O, including buffering, general device driver interface, and drivers for specific hardware devices. Protection and security. Protection. Any mechanism for controlling access of processes or users to resources defined by the OS. Security. Defense of the system against internal and external attacks. The purpose of virtualization is for efficient resource utilization, isolation and security, and simplified management and scalability. Next, distributed system. Network is a communication, and the most common TCP IPs are local area network, wide area network, metropolitan area network, and personal area network.
Now, let's move on to computer system architecture. So there are three main things in computer system architecture, which are single processor system, which have one core, multiprocessor system, which have multiple core, and lastly is clustered systems. Nowadays, multiprocessor system, which is also known as parallel system or tightly coupled system, is growing in use. This system has 2 or more processors in close communication sharing the computer bus and sometimes the clock, memory, and peripheral devices. The advantages of the multiprocessor are it increased throughput, economy of scale, and lastly, increased reliability. So there are 2 types of multiprocessor, which are symmetric multiprocessor and asymmetric multiprocessor. As we can see on the left side of the video, which is symmetric multiprocessor, all the processors are identical and they share the main memory. And on the other side is asymmetric processor, all the processors are not identical and they follow a master-slave relationship. Like multiprocessor system, clustered system gather multiple CPUs to accomplish computational work. They are composed of 2 or more individual systems coupled together and it provides high availability. This can be structured asymmetrically or symmetrically.
Next, we move to computer system environment. Computing environment consists of traditional, mobile, client-server, peer-to-peer, cloud computing, and also real-time embedded. In traditional computing model, networking becoming ubiquitous, even home systems use firewalls to protect home computers from the internet attacks. Mobile use IEEE wireless or cellular data networks for connectivity. It allows new type of apps like AR. Mobile leaders are Apple iOS and also Google Android. Client-server computing is a dumb terminal supplanted by smart PCs. Many systems now service responding to requests generated by clients. Compute server system provides an interface to client to request services such as database, while file server system provides interface for clients to store and retrieve files. Peer-to-peer is another model of distributed systems. Peer-to-peer does not distinguish client and server. Cloud computing delivers computing, storage, even apps as a service across a network. Logical extension of visualization because it uses visualization as a base for its functionality. Cloud computing consists of public cloud, private cloud, and also hybrid cloud. A real-time embedded system most prevalent form of computers. A real-time OS has a well-defined fixed time constraint. And lastly, free and open source operating systems. Operating systems made available in source code format rather than just binary, closed source, and proprietary. And one of the examples is Linux.